We're going to look at our last problem for rational functions and graphing with the 7-step process. The first thing is to find the symmetry, if there is any, or to check for it, problem, and we're going to test for symmetry. Remember, what you have to do is plug negative x into all the x's. And to test for symmetry to the y-axis or even symmetry, you want to get back the original. But you can use that same answer then and compare it to the opposite of f of x for odd symmetry. So first we will go ahead and plug negative x into all the x's. So I have replaced every x with negative x. You do need to keep parentheses where you have exponents. So we'll clean this up, and this will still give us back x squared. The two negatives here will give us positive 2x minus 15. This exponent of 2 will give us positive x squared minus 1. So this is f of negative x. First we want to see, does it match our original? It does not right here because we have plus 2x and this is minus 2x. So we do not have even symmetry. Right? And then to test for odd, we'll keep this here, and we want to look at negative f of x. And so if we just put a negative sign in front of the entire fraction, and then it could distribute either with the numerator or the denominator, but not both. So if it distributed through the numerator, you would have negative x squared. Okay, that is not the same as this, so that is out. If we distributed it through the denominator, it would be negative x squared, and so that is out. So there is no odd symmetry. So answer to our first question is there is no symmetry. Our next step is to find the y-intercept. So we plug 0 into x. So f of 0 equals 0 squared minus 2 times 0 minus 15 over 0 squared minus 1. Well, these are gone, this is gone, so we have negative 15 over negative 1, which gives us positive 15. So our point will be 0, 15 for a y-intercept. Next, we're going to look for x-intercepts. Remember, for x-intercepts, you set y equal to 0. Well, this whole thing, this is y. And to set that equal to 0, really, if you just set the numerator equal to 0, that's all you need, because 0 over anything gives you 0. So we're going to have 0 equals x squared minus 2x minus 15. We have a quadratic equation. This one looks like it will factor. So it's a trinomial. We're going to have different signs in it. And how about 5 and 3? And we want a negative 2 coming back. So we're going to need negative 5 and plus 3. Double check. Minus 5x plus 3x minus 2x. That works. And so if our first one is 0, then x will be negative 3. If the second one is 0, x will be positive 5. So we have two x-intercepts, negative 3, 0, and 5, 0. Next, we'll look for vertical asymptotes, and remember, you look at the denominator. So we want to know, when is the denominator 0? And this is a difference of squares. So at x equal -1 and x equals +1, we have vertical asymptotes. Next, we look for horizontal asymptotes, and remember we're going with our little table, looking at the degrees of our numerator and denominator. The degrees here are equal, so you take the leading coefficients. So it is 1/1. So our horizontal asymptote is going to be y equals 1. A question that I like to ask here is, does the graph cross the horizontal asymptote? So set the function equal to this horizontal asymptote and solve. So we'll just make this 1/1, and you can use a proportion here. So this times 1 just gives us x squared minus 2x minus 15. And on the other diagonal, we would have x squared minus 1. Right, you have x squared on both sides. You would want to deal with that first, but when you subtract it, those are going to cancel. And so you have -2x minus 15 equals -1. Linear equation, so we're going to be able to solve this. We're going to add 15 to both sides. Will give us 14, and we will divide by -2. So x will give us -7. So at -7, 1, our graph will cross the horizontal asymptote. Next, we'll put what we know on our graph. And so for our y-intercept 0, 15, this is 7. So 15 is going to be way up here. -3, 0, 5, 0, right, our vertical asymptotes, x equals -1. So we'll do a dotted line through -1. And x equals 1. And our horizontal asymptote y equals 1. Let's put a different color. Right, and then we are ready to find our points, and we're going to cross this one at -7, 1. So -7, 1, this is going to touch right here and cross. We want points in each region and in between the intercepts and the asymptotes. So we're going to just pull up our graphing calculator and then take the table from it. And it's good practice putting those in. So we've turned it on. We'll have y equals. Make sure that's cleared. And remember to put these rational functions in. You need parentheses on your numerator and denominator. So I'm going to put parentheses x to the second minus 2x minus 15. Remember, if you have the TI-84s, that you need to get your cursor back down after you do that exponent. Right, and close that parentheses. We're going to do divided by, start a new parentheses, x to the second minus 1. Again, with the TI-84, you would need to come down there with your arrow button off the exponent position. Right, and let's just go ahead and say graph here. So this is what our picture is going to look like, and you have to be a little cautious because of your window, because remember, we have a point in this section way up here, and our window is probably standard here, just going to 10. So we have to also get that point. But first, let's look at our table so we can get our points off. So second graph gives us our table, and we want to see -4. So let's make it go down some. And so we get 0.6. I'm not sure if this will let me. All right, it's not going to let me write and have the calculator at the same time. So I'm going to talk through it and then I will write them in. So -4 is 0.6. -2 is -2.3. 0 is 15. 4, we'll use our arrow button. -0.46, so about -0.5, and 6, 0.25. All right, so I'm going to move the calculator so that I can write on the screen. So now we're ready to get our points in between. And remember that your graph is going to go toward the asymptotes in each section. So -4, it is going to be at 0.6. So it's here, this line, it's crossing that a tiny bit, but this is the way it's going to go. It's going to go down toward this asymptote. It will not cross a vertical asymptote. So at -2, 1, 2, it's going to be down here somewhere. -2.3 from our table. -2.3, about right there. Right, so we can draw the rest of that, and it's going toward that asymptote. Right, we need this section, and 0, 15, we have way up there. And it's going to go toward the asymptotes. So right, let's look at 4. 1, 2, 3, 4. -2. Point about right here. And then 6 will be 0.26, so tiny bit up here. So this one is going to go toward this asymptote and toward this asymptote. I would probably pick a 0.5 that's not on the table, and maybe a -0.5. And I'm just going to give you answers to these. So if we pull back up our calculator, and this is something else with the calculator I want to show you. I am not getting these points in between. So what I would like to do is change my table and make it go by 0.5. So if I do second and this one table set, all right, so I'll enter, and this is my increments. I'm going to change that to 0.5 so I can get these values in between. Right, and now I'll do second table. And now I can get those 0.5s, and the one I wanted to look at is just 0.5. So it is 21. So I wanted to look at between these asymptotes and this intercept. And so it's going to go up this way, and if you looked at the -0.5, it will also be up. -0.5 is 18. So it's going to go toward those two asymptotes going up. The last problem we'll look at uses a transformation. So we're giving the graph of 1 over x, and we want to transform it into this graph. And so first of all, our plus 2 is in with the x. Remember, it will go the opposite way, and this is a horizontal shift. So this is going to go to the left 2, and this minus 1 is after our function, so it is going to go down 1. That is a y movement. Right, and so it would be good to have your asymptotes. It's kind of hard to move these points. You could get your table, do the work to your table. So subtract 2 on the x's, subtract 1 on the y's. That would give you your new table to draw it and make it easy. You can do it on your calculator. Let's talk about the asymptotes for a minute. It's also going to move them. So our asymptote right now, our vertical asymptote is at x equals 0. And so now our new vertical asymptote is going to be at x equals negative 2. This will be the new vertical asymptote. And your horizontal asymptote from our little table, our degree of the numerator is less than the degree of the denominator. So it is y equals 0. We're going down 1, so now our horizontal asymptote will be here. So that just helps us a little bit. And let's look at just a couple of little calculator items here. One thing that I have that I haven't shown you before is I have both of these functions typed in to graph, but if I want to see them one at a time, I can turn one of them off, and you just click on that cursor, and if it's not highlighted, it's not going to show that one when it graphs, right? So you can turn it off and on, and you would just click enter to turn it back on. Right, now it's highlighted. So I'm going to turn it back off. The other thing I wanted you to think about here is you want this minus 1 to go after this whole function. So what I did was put all of my fraction in a parenthesis. So I have 2 sets of parentheses. This is for my whole fraction so that my minus 1 is after the fraction and not on the denominator. And this is for my denominator. Right, so I'm going to graph it on here. So let's just say graph. It's only going to graph the first one, which is what we already have. Right, and now I'm going to go back in to my y equals, and I'm going to turn that other one on. So I just get my cursor back on it, click enter, and now I'll say graph, and it will add that picture to it. And notice it moved my vertical asymptote. So that is my new graph. Just it's shifted left 2 and down 1. Here's what your new graph looks like.